All right, let's get started with our exam review. Go ahead. All right, I think everything went well with my Blackboard settings. The solution should come up for homework 2.9 here in an hour, and I believe 2.8 is already uploaded. If not, it'll be up by noon. I can check that here in a bit. With that, let's go ahead and just jump right into it. Now, I did want to remind everybody about the grade distribution for the exams. The exams are not equally weighted because the way that I like to operate this class, I like to cut the exams off on topics. Like, we're done with tension members, right? So let's have a test on that. We're going to have our second test is going to be on bolts and welds, and we're going to cut it off and do the test on welds. And the thing is, so bolts and welds is a very nice sort of breaking point for an exam, but those are also pretty small topics. I didn't want to make that exam worth a lot because it's just not a lot. So this exam's worth 20%. Let's talk about logistics. So I did say we're going to do a paper-based exam, unlike last time where we did it via the computer. But I am going to let everybody use their notes and whatnot. So if you want to bring in your manuals or accessing the slides and whatnot, laptops, I am fine with that. My big thing, and I am going to be watching out for this on the exam, just know other people, Chegg, stuff like that. I do tend to think that it will actually result in wasted time, and you end up, if you actually just did the problem, you'd end up doing just fine. I've been teaching this class for a while, and the time critical aspect of the exam hasn't been too much of an issue. I don't think it's really been too much of an issue for all my exams, but I again, as I've mentioned before, like, I design these exams so that, like, I can complete them in 20 minutes, right? And if I can complete them in 20 minutes, then the idea is you should be able to complete it in an hour. Format is going to be the same as I've done for just about all of my exams. So there's a series of conceptual questions and then 2 to 3 computational problems. So you've had me for class before. You know how I do my exams. I haven't really changed. Bring your manual. Bring your open notes. You can use any resource that's on Blackboard. That includes the lecture notes, the recordings. It's not technically on Blackboard, but the OneNote, you can use that as well. I have no problem with that. One thing I would caution, this is one thing that I actually think does become a little bit of a problem on this exam, is I want to make sure that you understand the process and the concepts. But if you see a problem on the exam and you just start regurgitating what was on, I don't know, homework 2.6, that might actually not be the way to go. Because, like, for example, if you're doing a channel versus doing an angle, that changes shear lag factors, right? Because you have different cases for the U value. So just make sure that you're not just regurgitating homeworks and exams and whatnot, that you're actually paying attention to what's asked on the problem. One thing I will say is that steel design problems they can be kind of long. Like, design problems can be carried out and can take a long time. Sometimes what I will do is give you values to make the problem go faster for you, but that means you need to read the problem, okay? So don't just, on instinct go, oh, I need to do this, and this. Actually read the problem. There might be some data I gave you to make the problem go a little faster, okay? Because I don't want this to be a time crunch. All right, let's talk about the topics. So this is pretty much it in a nutshell. So in terms of what's on the exam, so there's really only 2 main modules. That's the fundamental stuff we did at the beginning, and then tension members. This is an exam on tension members. So the fundamentals, make sure that you generally understand, structural engineering process, what design means, what's the difference between ASD and LRFD, basic steel properties. I think that's pretty straightforward. Tension members, though, that's the star of the show. So make sure that you can analyze tension members according to the following limit states. So your strength limit states are gross section yielding, net section fracture, block shear rupture. And so by analyze, I mean determine the capacity, the design capacity, VPN. Also make sure that you can assess slenderness limitations. I also want you to be able to design economical sections, plates, rolled sections for prescribed loadings. So by design, most economical means the lightest weight. That's what I'm after, the lightest weight that will safely withstand the load. And also threaded rods. Make sure that you can analyze or select threaded rods for prescribed loadings. This, as you know, what I try and do in my exam review slide is I try and summarize the greatest hits, if you will, of my slides for the past few lectures. So if the past 13 lectures have been my albums, these are my greatest hits, because this is, I think, it's not everything, but it's a really good summary of everything we've been talking about between the beginning of the class and what will be on the first exam. So LRFD limit state, so this is generally our process. We deal in factored loads and factored resistances. So our factored loads are like 1.2 dead, 1.6 live. Our factored resistances are like ppm. And as long as our resistances are bigger than our loads, or our factored resistances are bigger than our factored loads, then the structure is safe. Here are our load combinations. Okay, 1.2 dead plus 1.6 live does tend to be the star of the show more often than not. But if you got a bunch of loads, you plug them into all the applicable load combinations. Whichever one gives you the biggest answer, that's the one you use for your design. The top two are the ones that are the most frequent. Tension member limit state. So we have gross section yielding, net section fracture. That block shear rupture didn't really fit very well all on one slide, so that's on a later slide. So 0.9 FYAG, so 0.9 is the resistance factor, FYAG is the nominal capacity, and then the nominal capacity is computed by taking the yield stress, multiplying it by the gross area. The net section fracture, the resistance factor is 0.75, the capacity is FUAE, but AE is just the net area times U. So we need the tensile stress, the net area, and we need the shear lag factor. So FY and FU, you get that from table 2-4 for rolled shapes, table 2-5 for plates, which, by the way, for most of the grades of steel that we deal with in this class, there's no real appreciable difference between the values for plates and the values for rolled shapes are pretty much the same. Like FY is 36, like for both and whatnot, in grade 36. We do need the expression for net area. So the net area is computed by taking the gross area and subtracting any area loss due to the presence of bolt holes. We subtract bolt holes by taking the diameter of the hole times the thickness. And the diameter of the hole is computed by taking the diameter of the bolt and adding 1/8 of an inch. Remember, we had 1/16 of an inch for the actual erection tolerance, the actual drilling process. The hole is actually bigger than the diameter of the bolt. And then we add another 1/16 for that lip of damaged material around the hole. Now, gross area minus the area loss due to the presence of bolts, that's enough for parallel bolt pass. For staggered bolt pass, we need to add the stagger factor, S squared T over 4G. S is the longitudinal spacing, G is the transverse spacing. Now, everything I just said about net area is for bolted connections. For welded connections, the net area equals the gross area because you're not removing any material if you're just placing like fillet welds and whatnot. Shear lag factors. So these are in table D3.1. Case 1 and case 2 are really sort of the initial two that you should be looking at for every member. But keep in mind that multiple cases may apply for a given connection. For example, angles, you have case 2 and case 8. W sections, dependent upon how they're connected, case 2 and case 7. So make sure you're looking at multiple cases. This is a table probably worth tabbing in your manual. I'll go through the tabs that I recommend here in a little bit. Here's our step-by-step process for design. We're going to determine the factored load. We're going to determine our two design parameters, so the R value and the AG value. So those are the guides by which we look up a member, okay? Now, once we find those two values and subject to our problem constraints, select the lightest channel, select the lightest W10, whatever, we're going to select the lightest shape available based on these two design values. Once we get that shape, we must analyze it because there's a lot of assumptions right here with the net area and with shear lag. So we have to analyze to determine or to verify that the member actually works. And first off, an easy way of doing that is to check its efficiency, which is what you do in step 5. The efficiency is the load divided by the minimum resistance, so minimum limit state performance, and then as long as that value's 90% or bigger, you're probably pretty good. One thing I will mention before we move on, I am not interested in you doing 100 iterations on the exam. If you are doing 100 iterations, you're probably doing something wrong. So something to keep in mind. I'm not trying to make you do the same problem 100 different ways from Sunday. Block shear capacity. So block shear is another limit state that we need to assess. Don't forget your resistance factor. It's easy to forget that once you've done all this math for the block. The block shear capacity is the minimum of the tensile capacity and the shear capacity, and the shear capacity, let me restate that. The block shear capacity is the sum of the tensile capacity and the shear capacity is the minimum of gross section or shear yielding or shear fracture. So we need Fy and Fu, and we need a whole bunch of areas: gross area and shear, net area and shear, gross area and tension, net area and tension. The methods are the same. We are not going to deal with stagger on block shear, so don't worry about that. And UBS, we're not going to have any cases where UBS is not 1, so don't worry about that. Last slide, threaded rods. Once you get your load, it's really just a plug and chug into this expression, and then pick a threaded rod. That's basically it. One final thing, and then I will shut up and leave time for questions, and I will put this on the screen. All right, so let's talk about tab sections. In other words, where to put little sticky notes in the manual. This is my recommendation. You do not have to do this. Do it or don't, But if you look at my manual, mine's got a bunch. You do not need this many, okay? So you really don't. But if you are going to put some, table 1, and by table 1, I mean the properties, like the dimensions of the channels, angles, and whatnot. What I have in my manual is the W shapes, the C shapes, the L shapes, and the WTs. That doesn't mean I won't ask you stuff outside this. I mean, I very well could, but this will get you 95% of all the problems that you would get on the as a structural engineer, not just on some exam.
Do you know if the other 5% is that we would need on the exam?
Well, everything else. I mean, that's basically what I'm saying. Table 2-4, which is where the Fy and the Fu are, and table D3.1, which is where the shear lag factors are. And I don't think you'll need anything else on this exam. If you know where your formulas are, like if you have your formula references, I don't think you'll need anything else. I really don't. Yes?
What's the 0.6 on the block shear?
What do you mean?
You said it's not a safety factor.
It's not a safety factor. What is it? That's what you're asking? It's not a safety factor. I can hear it now. I said, don't put that it's a safety factor. And then I ask the question, and then I just get a bunch of people say, it's not a safety factor. But that doesn't say what it is. That just says what it's not. It's also not a balloon animal, but that doesn't say what it is. Remember, it is a reduction in efficiency based on the von Mises yield criterion that says that if you have an element that's subjected to shear, it will yield at around 60% of the yield stress. I can hear it now. Can you say that again slowly?
Is it it on the slides?
Yes, it's on the slides.
Can you still say it against the
No. At some point, you got to do some studying.
Down.
What if I just don't get this uploaded by Monday? Shucks, I'm a really busy guy.
You're going to get like 30
It is in the notes. I did discuss it during the block shear lecture, by the way. But yes, it is a reduction in the efficiency of a section that's subjected to shear. Like, it will actually yield when the stress hits not Fy, but less than Fy. I'm pacing around the room, and my watch thinks that I'm, like, running. I don't know why. I'm not.
You're that fast.
And what's the difference between ASD and LRFD?
Okay, remember, ASD just uses a blanket factor of safety. Whereas LRFD, you're factoring your loads and resistances separately. Oh, God, I thought of something great.
What do those stand for?
Phrases.
Okay.
I thought of something messed up. I said, this is giving me a big list of questions to not put on the exam.
Hey, if you don't put these on the exam, I'll
Well, what about everything else I can put on the exam?
I don't know what else you can put on the exam.
We just go slide by slide and ask you everything. Then,
I've never had anybody try that. Like, okay, let's go to lecture 1, slide 1. So can you tell me about the announcements? Like the first day of class, was that a Monday? Yeah.
Can you go over every problem you've ever done?
Yeah, I'm not doing.
The homeworks you assign.
Yeah, I really will be going fast then. What burning questions have you had though about like the concept? Are there any problems, any concepts, any homeworks, any? Floor is yours. How are you feeling about the exam? Nervous? You feeling?
Not nervous. So, I think it's when we were doing the block shear lecture. In some cases, like the shear path was like on the edges, or it wasn't in the middle. She said we multiply it, so we find, or we don't have to do separate calculations. But if it's on like a WT and it's on the flanges, the edges of the flanges, so there'll be 4 different shear paths, right?
Well, not if it's a WT. If it's a WT, there'd be 2, right? If there's a W, there'd be 4, right? But what I propose is that whenever you have multiple failure blocks and they're identical failure blocks, what I would do is just determine the capacity of a single block and then multiply by the number of blocks present. You know what I mean? So, here's what I wouldn't do, and I have had students try and do this, okay? So like, for example, let's say you're doing the shear path, and let's say one block you would remove like 3.5 bolt holes. So what they're trying to do is say, okay, for all of them, it's the gross area minus 14 bolt holes or something like that. I wouldn't do that because I genuinely think it's harder to keep everything straight. I wouldn't do that. I would take one block at a time and multiply by the number of blocks. That doesn't mean that you couldn't use the other approach correctly. You can. I just think it's harder to track. That's just me.
Could you also add on the, I guess you're saying you determine the capacities of like each section?
Yes.
I think on the homework I did it by like finding the area and then adding them all together or something like that.
You probably made it more complicated than it needed to be. Well, there's got to be other questions.
For yesterday's homework, you just have to find the dead load and the live load, and then factor it, and then plug it in.
Yep.
Okay, great. I did it right.
No, I mean, yeah.
Can you remind me what 0.6 is? You already gave a spiel about it.
You missed it. I did.
Somebody give
Not
it to
a
me
balloon
separately.
animal. It's not a balloon animal.
It's not a safety factor. I don't know what it is.
What I was saying though is that all these questions were giving me a really good list of what not to put on the exam on Monday. Yeah, everybody's well prepared for these, and I got to come up with questions you're not prepared for. So.
What is verbatim with the question prompt?
Can we just see the exam real quick?
Yeah.
Can we have 5 minutes to look over the exam?
Seems pretty nice.
Like it's for our our well-being. We're just looking out for you, Dr. Mike. We wanted to make sure there weren't any errors on it. We're trying to keep the tally count down.
We don't want you to waste too much.
Okay.
If you let us see it now, we can also do it in 20 minutes like you.
There you go. Hold on. Yes, sir.
So I can't remember exactly what.
Hold on. Shh. I need to hear this.
What value you're trying to get when you do this, but like if you have a W8 by 24 and you need to find the equivalent WT, you do cut it in half, so it's like a W4 by 12.
Yes. And the reason is because take a W section and cut it into a WT. It is literally half as deep and half as heavy. So you just take both numbers and divide it by 12. There is a corresponding WT for every W shape. So, yeah.
Is that even like the wonky ones that are like W8 by 15s or whatever?
Yes, there are. So there will be something like a WT 7 by 26.5.
Is this something we need to write down?
Sure. No, but you don't have to believe me. Open up your AISC 15th edition steel construction manual to table 1-8, and you'll see that there are WTs like WT 20 by 327.5 and 99.5. Like that's what they are. Okay. So if the weight is odd, that'll happen. What I'm getting at is you're not going to find a scenario where you cut the W shape in half and there isn't a WT in the main. That's not going to happen. That won't happen.
So the exams are more paper-based now, and that means that, like, so in Blackboard we would often just have to write the answers, and I assume we're going to have like more space on this.
Yeah. I'll give you an exam and give you scratch places to work. You'll have enough room.
Okay.
I'm not going to make you do this. I won't do that.
You do partial credit?
I've always done partial credit.
I haven't had you for like a year and a half, I can't remember.
That's right, yeah. Alejandro doesn't, but I do.
You're gonna teach.
And you missed it. We'll fill you in later.
You're gonna teach structures too.
That is so.
Yeah.
That is a good question.
Alejandro teaches structure.
He might be able to. I haven't spoken to the chair about it yet, but I'm going to try and see if we can do it next spring. I'll try.
I think Alejandro has a pretty free schedule, right?
Okay, yeah, he's. You don't want Alejandro though for class. I'm just saying. Now, if I can, I will try and do that next spring, and I'll go ahead and tell you what it will probably be like. It will probably be 3 main topics. It will be some advanced indeterminate analysis. It will be some building system stuff and some bridge system stuff. That's probably what I'm going to do, is those 3. So like live load distribution and live load reduction in buildings. Basically, that's kind of the idea. So I'll go ahead and tell you the problems are going to get longer. They are, and there's nothing I can do about that, But maybe we'll throw in some funicular structures. Funicular structures, otherwise known as cables and arches. Plus, that's just an awesome word. Funicular. Yes. All right. Any other? Come on, come on. We got time's waste. I know you all have more questions than this. Yes.
When grading, do you do double jeopardy?
Do I what?
Double jeopardy is like if you get like one thing wrong at the very beginning, but you still are able to find the final value out of it.
No. Everything no, I don't do that. So here's how ideally my point deductions work. So like I'll build a spreadsheet for a given problem and copy and paste that for every student, right? And if this value is wrong and I change it and I arrive at the same answer you do, then it's just that value that causes the deduction, right? And so that's how I grade.
Okay.
Now, a couple other things. It takes me a while to grade because I really try and ensure that if there's any common deductions that I'm being commensurate with my point deductions. I don't want to take 4 points off for you and 12 points off for him. I don't think that's right. So I try and be consistent. But let me also say this. There are times when I am grading a problem and being as nice as I can be when I say this, sometimes I don't know what you're doing, and I just have to go, this problem's worth 20 points, minus 13, and it's because it's hard to categorize it, Does that make sense? So I try, but again, I try and be fair. I don't grade students one by one. I grade problems one by one. So when somebody will ask me, how did I do on the exam? I have no idea how you did on the exam. I know how problem 6 did, I know that seems silly, but by grading each student's problem one at a time, it ensures that the deductions are consistent. Does that make sense? So I will probably still email the grade reports, though, like I did last semester, and then I'll just give the hard copies back. So I might actually not mark up the hard copies. I'll just email it to you. Because I can still do that. Oh, there's got to be more questions than that. Everybody's talking about grading. What about steel design? That's actually kind of important since that's going to be on the exam. I mean, in all honesty, are there any questions about steel? Yes.
I feel like if we face a problem like we did last night on that homework, when we did that tributary area, I know that like would it matter which rod you selected on that homework last night?
No.
I was just curious because like the end rods, when I first read the problem, I assumed that there would be 20 feet on the end.
No. The idea is that you were to assume that the walkway was infinitely long, and every rod just is spaced 20 feet apart, right? So for the dead load, right? Okay, well, let's talk about tributary area, right? So each rod spaced 20 feet apart, right? So the tributary width or length, however you want to call it, is 20 feet, and then the width is 3 feet, because the walkway is 6 foot wide. So if you got 2 rods, half goes here, half goes there. So the tributary area for 1 rod is 60 square feet, right? So for the live load, you take your pressure times tributary area, boom, there's your live load on the rod. Dead load, you take the tributary area times a 4.5 inch thickness, there's the volume of concrete per rod. Concrete weighs 150 pounds per cubic foot. There's the dead load. 1.2 dead plus 1.6 live. Boom. Was that the most challenging homework we've had all semester, that one? What was the most challenging one? The stagger factor ones. With 800 failure pass. The purpose was so that you could identify them. The math gets real repetitive, and I understand that. But the purpose is so that you see them. And hopefully by now everybody sees them, right?
I just did the one I thought would be the best, and I did like another one. I couldn't do all that.
But you saw them.
Yeah.
That's the point. Did you see them?
That was one of the classes I missed, and I didn't get it very, but I get it now.
Okay. Yes, you're about to say something.
Is there gonna be like any, like I know there's gonna be a stagger factor problem, but is there gonna be any with like more than like 6?
So again, well, I'm going to answer that question the way I'll give you a generic answer. I'm not interested in repetition, and I'm not interested in time crunches. That's the best way I can answer it. Like, I'm not interested in making you do the same thing over and over again because I don't think there's any educational value in it. To me, I would rather ask you different stuff, you know? The way I see it, I got 50 minutes and I want a well-rounded exam. A well-rounded exam means it has to be diverse, but you can't have one problem that you're just doing the same thing over and over and over again. That doesn't mean there isn't some iteration, but it can't get crazy. That's my philosophy. So. Any lingering doubts? Any?
Is it always true, like, when you're looking at a stagger factor, the one that has the most staggers is gonna be the one that,
The most stagger
or
factors?
the most, I guess, diagonal paths. Is that gonna always be the one that?
So, not necessarily, but there is something to be said about you staggered it for a reason. If you're the engineer and you're the one laying out the connection, then you're obviously laying it out such that you're getting that benefit of the stagger. Do you know what I mean? That doesn't mean that's always the case, you know. That's probably the best answer I can give you. So if I was giving you a practical answer to that question, I'd say probably. Do you know what I mean? But
That's the pattern that I've noticed. I didn't know if that was always a trend.
no, well, I mean, there's a trend to it, but probably doesn't mean I wouldn't check all of them. You know what I mean? Like if I'm designing a bridge that my grandma's going to drive on, and I'm not going to use that probably to, you know, it's a gut check to see whether or not things make sense. You know. Nose is itching. Let me ask this: any other big ticket questions? I feel like we're hitting that point where we don't have anything left to ask.
I have a question unrelated to the exam.
You have a what? A question unrelated to the exam?
Yes.
Oh boy. About what?
No, so I was looking at like my blackboard, and it says my homework averages are 93%, but all the homeworks, grades I have in are like a 10 out of 10, and I wondered how that happened. Or is like there are grades that aren't showing up yet?
There might be grades that are invisible. Like, so I usually turn them on as they are graded, but I've been at green and white day all morning, so I haven't. Yeah. So the last time I looked at it, I think we were up to 2.6. So my TA might have graded the other two, and I just hadn't turned it on yet. So my apologies, by the way, about the exam 2 and the exam 3. I know everybody was excited about their 96s on the exam, and whoops. I'm sure you were. In all seriousness, though, in this course, I do think the second exam is the easiest, and I don't mean to scare you, but I think the final's the hardest. So this exam's probably right in the middle. And the reason the final's the hardest is just because it has more on it. Like columns and beams are actually kind of a big topic. Like they're big, you know. The design process for columns and beams is a little bit more involved. There's a lot of tables and charts that you have to reference that you don't really have to do with tension members, because with tension members, you just do some math, find a shape, and then check it. Whereas with columns and beams, the actual, bless you, the math is so complicated that you can't really find the most economical solution without some aid or chart. I would argue that those aids and charts are the reason you had to spend $125 on this manual. You know, it's those are what you're spending your money on. You can actually download the spec for free. You can download the shape database for free. It's the aids and the design charts. That's what you're paying for. So, in fact, they are so necessary that if you open up the FE reference manual, some of those are printed in the manual because you can't do steel design without them, you know. So, but I'll show you that when we get to that point. All right, any other questions? Because I think we're hitting that wall. All right, hold on. Are you good?
Yes. Good.
You good? Any more questions?
I'm good. Are you good?
I think I'm
Do
peachy.
you have any questions?
I don't have any. Well, actually, I do have some questions. I'll ask them on Monday. I do. I have 4 to 5 conceptual questions.
I already hear your questions. You don't have to wait.
I don't have to wait. Y'all good in the back? Y'all good back there? Everybody good?
Send us the questions ahead of time so we've got a good response.
Well, I tell you what, I will pass out the exams a few minutes before 11 o'clock on Monday.
Okay.
And I'll put a little heart on them because it's Valentine's Day.
And you're giving us Sunday, right?
Oh, man. We'll see ya.
Catch you later.